Good morning, everyone, and welcome back to day 2 of CUTRIC's second annual Zero Emission Bus Transit and Technologies Conference. Before we begin, I'd like to share that we have closed captions available in both French and English, so you can enable this tool by clicking on the button directly below the video stream. My name is Grace Riley. I lead Government and Public Relations here at CUTRIC, and it's my pleasure to welcome you to our panel, Innovations in Charging Solutions for Transit Agencies Ahead. If you heard my flubs during our opening remarks, you can tell it was a long day yesterday with a virtual conference, a federal funding announcement, a ZEB consulting product launch, and an in-person event. We packed it all in, so my brain mustn't be keeping up. Just bear with me as we go through this panel. Thanks very much for your patience. I'm joining you from Toronto, Ontario. In the spirit of reconciliation, I'd like to take a moment to acknowledge we are on the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabeg, the Chippewa, the Haudenosaunee, and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis people. We acknowledge that Toronto is covered by Treaty 13, signed with the Mississaugas of the Credit, and the Williams Treaties, signed with multiple Mississaugas and Chippewa bands. I would like to thank our sponsor for today's panel, Hitachi Energy. Our conference would not have been possible without our sponsors, so thank you very much for your generous support. So with all of that, I'd like to welcome our panelists to today's session. First up, we have Tanya Krakiewicz, Vice President of Special Projects at eCamion. Welcome, Tanya. We have Milford Hammerbacher, Founder and CEO of S2E Technologies. We also have Paul Netzband, Managing Partner at Equicharge, Will Christopher, Business Development Manager at Car Media Lab, and last but not certainly least, we have Alexandra Lalonde, Business Development Manager of North America EV Charging Solutions with Hitachi Energy. So as you can see, we have an absolute jam-packed session. And so with that, I want to kick things off. Before we do, I just want to check in that our panelists can activate their video and microphone. There we go, Tanya. Hi, how you doing?
Hello.
All right, so 5 panelists, lots of presentations, and a really deep dive Q&A to come. Let's get started. Tanya, over to you.
Thank you. Happy to be here. So yeah, I'm going to take the opportunity to talk a little bit about a pilot that we're conducting presently with Durham Regional Transit. It's long held for us to get into the transit space and deliver our value here. So this is exciting, an exciting project for us, and I'm happy to share it. Let me just, here we go. If I could introduce eCamion. We've been around since 2009. eCamion is specialized in energy storage-based DC fast charging infrastructure. And our sweet spot is really delivering power in ratings from 50 kilowatts to 600 kilowatts, and doing that without taxing the grid and without exorbitant make-ready charges and make-ready costs. A couple things that I wanted to point out is that we've been in this space for quite some time and have had the opportunity to test several use cases, everything from heavy duty fleet charging up in Alaska to grid support in Alberta to grid and energy management in New York, and just the traditional DC fast charging. And so our foray into the transit sector is exciting, and that is in essence what we're going to be focused on today. So the solution itself is dubbed the Universal Energy Hub. And if you have a look at the picture to the right here, what you'll see represented in the middle there is a little picture representing the hub itself. And the value of this hub is its incredible ability to be able to integrate and perform many functions at once. So the hub is capable of integrating at the facility level, integrating at the grid level, actually responding to utility programs inclusive of demand response, integrating to provision high-speed DC fast charging, integrating with renewables, also with 5G towers. And today we're going to talk a little bit about what that looks like as it relates to integrating at the transit level. So the main issues that we've solved by virtue of this technology is that we have figured out a way to put a battery in between the facility and the grid in such a way as to eliminate additional infrastructure costs when you are planning electric vehicle infrastructure. And of course, by virtue of utilizing a battery to do this, we are in a strong position to curtail and reduce demand charges. And that would definitely be the second value. I think another interesting point, and this has really been driven out of the software capability of the solution, is that we're able to do more than just deliver operational savings. We're actually able to, through the software capability, provision that same technology to be able to generate revenue. So if your utility has feeder programs, or if you have the capability of shaving peak at your facility, there are ways in which you can actually earn money as well as save money. And I think that that's made it a much more attractive proposition for people to make investments in these in the early days of electrification. As well as that, our architecture, I think, speaks well in terms of our ability to remain future-proofed and versatile. We've built the technology on a 1,000-volt platform, and so that enables us to be ready for the bigger vehicles that are coming down the pipe. The 7 building blocks that compose the ECAMian, value proposition are stated as you see them there. And so any configuration of these 7 blocks is really what drives to value. And today we're going to focus on the bus charging. I'm going to take us there. And the first application here is actually the context in which we are delivering value to Durham Transit. And you'll see that the little picture over there shows you that we're going to install an inverted pantograph that will be integrated to our energy storage system at the Farewell Depot in Oshawa. The specification for this pilot is a 180 kilowatt hour battery system that will be integrated with the pantograph as well as with the pedestal in the maintenance bay. And so both of those being capable of delivering 150 kilowatts of power. And the entire setup is actually going to demonstrate a couple of things. One, that we don't have to invest in significant make ready to actually drive this instance. It will be set up to support a pilot that is commencing with Durham Transit. And as well as that, it will have the capability to power share in between the pantograph in the bus bay and the pedestal in the maintenance bay. The second application that is actually being run right now through a feasibility study is the same technology being placed en route. And I think the thing that I would like to call out here is the very same power rating, battery rating, but if you can envision that there is no requirement for a significant power input. In fact, you can run this kind of technology with something as little as a 10 kilowatt input and any voltage. And that, I think, is actually what has caught some of our transit partners' interest. So in kind of giving an overview in terms of what the value streams are for our transit partners, definitely the use of existing infrastructure and a real reduction in CapEx costs as it relates to make ready. An estimated 50% OpEx reduction, which we intend to prove in the Durham Pilot Transit. And lastly, but not least, is the additional benefits that are going to be demonstrated through peak shaving by virtue of integrating with the facility. And I think in additional phases, we'll actually be able to take a look at some other revenue generating opportunities that come out of the same infrastructure configuration. So this is I'm going to speak just a couple minutes on this, a couple of seconds actually, on the energy assessment that we did in the early stages of the pilot to model whether we could meet the operational need of a transit authority with this configuration. And so we looked at a route that the authority had, 901 Pulse and Simcoe. And I'm going to just run through what some of the assumptions were on that. So the idea here was we took a look at the 16-mile route, 32 miles round trip, and we hypothesized two scenarios. So 2 buses charging every 3 hours, and 8 buses charging every 3 hours. So you can have a look at the assumptions on the right-hand side. And basically the net impact here was that we demonstrated that with as little as a 40 kilowatt grid feed, you could run that operational duty cycle and barely degrade the battery. And the same is true for the 8 bus scenario with a 200 kilowatt grid feed. All said and done, the objective here is to really demonstrate that we can actually reduce OPEX by 50% and CAPEX, again, by virtue of what we save in make-ready costs. Super excited to actually see this data come out live. And the last would be an optional phase to utilize the same technology for something like a global adjustment charge. I don't think I'm going to have time to get into this case, but for people who get the slides, please study it because it's actually quite interesting how this very same infrastructure that saves on OPEX can actually turn into a revenue generator by virtue of saving almost $250,000 in global adjustment. And I think that brings me to the end of my time. Thank you kindly for the time. Look forward to the Q&A.
Thanks, Tanya. Really, really interesting. I am excited to ask you a few more questions about the DRT pilot. I think it's great to see how much eCamion has grown over the past few years. So yeah, all right. Thanks, Tanya. Next up, we have our next panelist, Milfred Hammerbacher from S2E. So over to you, Milfred.
I think you can see me and hear me now, I hope. Hi, good morning, everybody. It's great to chat with you this morning. I love innovation. My company's been involved in a lot of different innovative things over the years, from designing sustainable communities, clean energy solutions, clean mobility solutions. And hopefully when I'm done with this talk, you'll kind of understand a little bit about what makes my company tick and what we're passionate about and why we're here. And maybe some innovative solutions that can help you achieve your goals faster and more economically. So it never hurts, at least for me, to show why we are here. Greenhouse gases come from a lot of sources, but certainly transportation is a big chunk of those greenhouse gases. And we can no longer say climate change is not here yet. The effects are all around us almost daily. And on the economic side, we really have a choice. We can do nothing and face the huge negative impacts of what climate change can do to the economy, or we can try to solve these problems and create new industries and new business opportunities. And that's why S2E does what they do. We feel like it's a moral obligation, and there certainly is an economic motivation. So that's what drives us. That's why we're in so many different things. But the thread that runs through all of our business is trying to make a difference. Fortunately, there's a lot of technology solutions today that are economical and proven. But also, a lot of these solutions were developed in silos. And working in silos can create some inefficiencies and unintended consequences, like renewable energy, great carbon-free, electrifying our transportation, also a great way to reduce carbon. But it can also put a lot of stress on the electricity grid if we don't look at a more holistic solution. If we went and replaced 25% of our fossil fuel cars today, it's going to create a huge demand on raw materials, a more demand on our mining, and they're already struggling with their carbon and environmental footprint. So a lot of things developed in silos can unintended consequences come from that. Another example is just energy efficient buildings. If you build this great net zero energy efficient building, but it's 25 miles from where the person works or to the nearest grocery store, you could lose all that carbon savings just by getting to life's necessities. So you really need to look more at a holistic kind of a solution. And that's the question. How do we take these great siloed solutions and fit them into a wider system? So we feel like one of the ways to deal with what we're talking about today is electric buses and how we charge them is to use a micro utility as a more holistic solution. The idea, and Tanya has already spoke of that, and who knows, Camion may be a partner in our project I'm going to talk about here, is you take an expensive asset and you try to create multiple benefits from that asset or multiple business or revenue streams. So the electric bus main purpose is to transport people from point A to point B. But what if that bus could also supply emergency power back into the grid or community? What if that bus charging system could actually stabilize the grid rather than destabilize the grid? What if those charging solutions could provide excess energy to the community when it's not charging the bus? These are all kinds of things that if we do this in a more holistic approach, we can actually create a lot more benefits. Here's a really sad one. In Ontario, we currently throw away about $1 billion of electricity every year. It just kind of makes me sick, and we've been doing that for a long time. What if the electric buses could be charged with that waste electricity? Kind of get the flavor of how a more holistic solution can really make the economics look more attractive. So I'll talk about a micro utility that we're working on in West 5 as a community in London, Ontario. I think one of the largest sustainable communities in North America. We started with the concept of building this net zero energy community, and we felt like a micro utility could add a lot to that. And the idea was we have solar on all of our buildings. We can tie that solar into, say, DC LED street lighting, and we can put in a 1.5 megawatt battery into this microgrid to basically perform resilience, backup energy. Not too long ago, we said, man, if we add another solution to this, we can really make the economics even more attractive. And that's when we started talking about putting an electric bus charge system into this microgrid. By using this system now, electric bus wants a very fast charge. We can provide that very fast charge from the battery and not have a negative impact on the AC grid. And then, as Tanya was saying, you can charge that battery up any time of the day. You can charge it up when the sun's shining on your solar panels, or you can charge it up in the middle of the night when electricity is cheaper, or you can charge it up whenever the Ontario grid's getting ready to give away $1 billion worth of electricity. So that's kind of the concept. I'd love to say we're building this, but COVID has just killed us, and we haven't pulled the trigger on building this. But I hope any day we'll be able to say shovels are in the ground on it. So that's kind of a technical solution. I know that was a simplified drawing, but anyway, I want to talk about what's a potential business holistic solution as well. So what if you have a bus service and all that bus service wants to do is have an affordable zero emission bus to get their customers from point A to point B. And then you have a utility that just wants to provide affordable, reliable, resilient electricity to their customers. Both of them have kind of siloed needs. And what if neither one of those entities had any money? So here's another business opportunity, a new entity, let's say S2E and its partners actually owns all that expensive capital. We could own the buses, we can own the micro utility, the solar system, the batteries, and then we could sell or lease that bus back to the bus service. We could sell the renewable energy back to the bus service or to the grid. We could provide emergency power to the grid. We could provide power conditioning to the grid. Basically offer all these things as a service and remove the capital upfront costs to the main users of this. So that's kind of trying to think out of the envelope here on how we can use holistic solutions to solve some of our bigger problems. And that's really the whole idea here is to use low emission energy to charge low emission electric vehicles and create a better environment for our kids. Thank you very much.
Thanks so much, Milford. That was a really interesting presentation. I have lots of questions, but I'll pause there for now. For those of you on the line who are hoping that this session is recorded, you are in luck. It is recorded, and sessions will be available hopefully next week. We'll give you an email when they're all ready. So with that, thanks again, Milford. And up next, we have Paul Netzband from Equicharge. Over to you, Paul. Just jumping in, Paul, if you go to the top left of your screen, you can give access to your video and microphone. Yep. There you go.
Should be working now. Sorry about that. Thank you for having Equicharge Solutions speak to the conference today. Just by way of background, my entire career has been in the innovation space for the last 40 years, from working with Nortel Networks and introducing digital cellular to advancing emerging standards in the electrification industry like SAE 3105. So today, I'm going to introduce what I believe is one of the most single important aspects of planning, scheduling, and operations for your zero emissions bus fleet, and that is charging operations. And charging operations contains several elements. Next slide. And so on this chart here, very simple block diagram, we've got CAD AVL, stands for computer aided dispatch and autonomous vehicle location. We've got integration with that to the dispatching and monitoring functions with inputs from the planning and scheduling system. There's coordination of charging operations, which we're going to talk about by a depot management system, if described in a more generic way, that is supported by inputs from a maintenance system itself. And what we find in general is that through experience in delivering these integrated solutions is that very often one component is either missing, that is the depot management system. It's either done manually. In a smaller property, it may be a magnet board, maybe a spreadsheet, but the integration is very low in either event. Really, when we take a look at the larger solution that's available today, typical components that are available out there supporting the depot management system come about by identifying what types of data is required for that depot management system. So the types of information needed to do that are real-time information coming from the zero-emission vehicles, localization systems, charge management systems, which of course integrate into standards-based coordination of chargers themselves, whether they be en route, in yard, or in depot. Energy management systems, which includes integration with building and facility management systems, solar and storage subsystems. So what do these components all do? There's a lot that goes on, and it's very complicated, as I think our keynote this morning identified, and the results from yesterday's conference presentations. But just to go through this from the bus, kind of left, right, effectively, the real-time data comes from zero-emission vehicles, which provides the dispatch and monitoring systems with energy consumption type information. For battery electric buses, for example, it might be state of charge information and other alerts that need to be collected into the dispatch and monitoring. That system will provide low energy alerts and other types of controlling information to the depot management system. But of course, that dispatch and monitoring system is also fed by planning and scheduling, which advises on energy needs, the distance of routes and runs, the actual charging windows that need to be coordinated by the depot management system to meet book out. If it's 24/7 book out, for example, if it's not just an overnight charging scenario. And the depot chargers we've got sitting on the top center of the screen in green, they of course provide the ability to actually charge the vehicles. The charging management system has a number of complicated characteristics and standards that integrate to these other components. And they allow, of course, being able to set charging, control charging and prioritization of the charging sessions in the right order and sequencing to optimize the power utilization, smooth out the demand peaks, make use of, for example, systems from Ecamion in terms of, bringing in energy storage that's been stored at other non-peak times. And then there's, of course, the energy management system itself that really is all about being able to dynamically in real time monitor the current power levels that are available, as a lot of these depots, integrated depots, also support fleet maintenance activities, and power can fluctuate dramatically in those type of facilities during the day. Different maintenance activities go. Now, the DMS itself, the depot management system, actually brings this all together and coordinates this. It manages the movement of the vehicles within the depot or the yards, assigns parking positions with chargers to ensure that charge can occur by the time that that vehicle is identified for book out again. And as we know, in many large municipalities, that can be several times a day that a bus goes in and out. It also manages the charger availability, and also allows for management of a variety of types of vehicles. The DMS does all that. And if we move forward again, what we're going to see overlaid on top of this are the transit functions that are supported. Now, all of the technology that I've just reviewed in this charging operations type solution, that's been presented fairly generically, appears somewhat complicated, but all these functions essentially support either a transit operation or fleet maintenance use case or activity that you do today, that is performed even for diesel buses today by and large. This chart highlights only just a subset of those use cases, of which there are literally hundreds in these facilities. And essentially, all of these types of use cases are required. And I'm going to pick on the depot management system in the center of the screen here. Return from service, servicing, recycling at night, work assignment of the fleet service and maintenance personnel. If we take a look at being able to handle changeovers en route, being able to effectively support blocking and run cutting and resourcing and aligning with what the principles of the unionized workforce for the operators are, and that's about it. I wanted to just fly through this real quick. Of course, EquiCharge Solutions is a provider of end-to-end solutions. We have many partners that support us, but we are very familiar with this end-to-end solution, and I'd like to thank Kuchuk for the opportunity to review this today.
Thanks so much, Paul. I love your presentation. I like how you've just really shown the whole kind of landscape. At Kuchuk, we always say it's a whole systems overhaul. When you electrify a fleet, it's not just buying the buses or buying the chargers. It is so much is involved. And, we see when we're modeling out like, a bus, like one bus to one bus replacement. Does that work? Well, if blocks are longer and routes are different, not all of the zero emission bus transit solutions can really, just transition from diesel directly. So thank you so much for your presentation. Really interesting. Looking forward to chatting a bit more in the Q&A. But without further ado, we'll go to our next panelist today. And that is Will Christopher from Car Media Lab. Over to you, Will.
Yes. Good morning, everyone. It is an honor to be here. I am Will Christopher, the North American Business Development Manager at Car Media Lab, which is part of the Init Group. Init is a global ITS provider focused 100% on public transit, and we help agencies optimize their operational systems and transition to fully electric fleets. We've got over 35 years of experience, 1,100 customers, and 1,000 employees worldwide. Okay. Init provides solutions for optimizing electric buses, ranging from energy and charge management, range prediction, depot management, planning and simulation, real-time fleet management. At Car Media Lab, we are the telematics specialist for smart charging, which is the perfect segue into our topic today, where I plan to share some challenges our customers are facing and 3 tips for mastering charge management. As you can imagine, bus depots were built decades ago without consideration for electric vehicles. Many depots are struggling with these energy grid limits. I hear a lot about that just in this conference. It's important that a charge management system needs to understand these limitations to design the charging process accordingly. Now, this means that when buses are plugged in, the charging process should automatically manage load balancing, and peak shaving to avoid energy tariffs. And I'll show you a helpful graph on this later in my presentation. The third point, and probably most important part of an electric bus, is the battery life. The battery life and health are critical to the long-term success of electromobility. And unfortunately, the faster you recharge a battery, the shorter its life and the less your return on investment. So smart charging means it uses the entire standing time of the bus to move energy as slowly as possible. Now, without a charge management system, you're nearly blind. You have limited information on the charging process and health status. So if something goes wrong, you must send out a technician to inspect or repair. And one final consideration is integration into subsystems like depot management and CAD AVL. Transit operators are facing a variety of differing IT systems. So it's critical that all pieces work in concert, regardless of who makes what. That's why it's important for your charge management software to be industry compliant and manufacturer agnostic. Here's a good visualization of how a charge management system acts as a centralized communication tool, communicating bidirectionally and linked to every part of the charging process. Now you see mobile charge there in the middle, which is the name of Init's smart charging solution. Now first, there on the left and right, your charging stations should be communicating with chargers along the route or in depot with full control, monitoring, and reporting of functionalities. Next, there at the top is the communication with operational information systems like CAD, AVL, depot management, planning. You want important operational data like bus arrival and departure time, state of charge, expected length of routes, and energy demand for the next duty block. Now, this can be done manually, but if something changes, you're unable to update the fleet in real time. However, smart charging knows to automatically adjust for a bus that comes in late or has a battery that's lower than expected. Another important interface is with your energy supplier and energy management system. This is where you get information for the availability of energy and the cost of energy. And in exchange, you want your charge management software to share information of how much energy is needed for charging so the energy supplier can prepare. And lastly is the ability to connect with a microgrid. You know, with these zero emission mandates and billions in new federal infrastructure dollars, transit agencies are investing in renewable energy generation and battery storage. A charge management system should be able to communicate with both the main grid and the microgrid. Here's a visualization that demonstrates how standard interfaces connect with a charge management system. When an electric vehicle is plugged in, the vehicle data is communicated to the charging station, either through JPlug or ISO 15118, which then communicates with your charge management software over the network using standard open charge point protocol. Now, they're kind of in the middle as a green block. It says preconditioning. A nice, smart charging bonus is that preconditioning. During the summer and the winter, when the temperatures are at their extremes, bringing the vehicle to temperature before being unplugged saves the batteries, which equates to increased vehicle range per charge cycle. Here's another slide with interface examples. The combination of the two bottom protocols allows for a truly optimized charge process. The ISO 15118 and OCPP 2.0 are what we call the dream team combination. Now, I mentioned earlier how the charging process should automatically manage load balancing and peak shaving to avoid tariffs. Here's a simulation example we did with one of our customers. It represents energy savings from an intelligent charging system that is designed to control energy loads by spacing out the process so there aren't any big surges, especially during peak times. And from this graph, you see the financial impact of peak shaving, which can decrease total energy consumption by 15%. Now, this graph represents load shifting. When an electric bus gets back to the depot and gets plugged in, it doesn't necessarily need to start charging right away. You know, maybe the charging process can start later when the energy prices drop, or maybe the battery doesn't need to be charged to max power. The system calculates energy needs and can adjust the rate of energy transfer, which means it doesn't jeopardize battery life. This brings us to the top three tips for mastering the charging process. Without a smart charging, the flow of energy is uncontrolled, which consumes max available power, wastes energy, and shortens battery life. Controlled charging means the flow of energy is constantly being monitored and optimized in real time based on your operational needs. The system accounts for balanced energy management. It knows if electricity prices are going up. The system knows that there's a failure, sends alerts. And with a web-based application, you can send out a tech without having to, you could restart, monitor and restart that issue without having to send out a tech. And, I mentioned the preconditioning. Second, almost done here, Grace.
Thanks, Will. Appreciate it.
Decentralized energy generation and storage provides further potential for maximizing your investment. You may not have solar panels yet, but like integrating electric buses, it's probably only a matter of time. Cost savings are the obvious benefit here. Energy is expensive. If you can create it on site, great. And if the main grid goes down, you do have the option of what's called island mode. And the third point is, as an electric fleet grows, the charge management software needs to be flexible and scalable and work well with others. Avoid proprietary software. You've got no idea who's going to win the next RFP, but you do know that they need to play well with others. And in closing, you could either host on-premise or in the cloud. It gives you flexibility in terms of implementation and pricing. And in closing, one of the core themes behind all this is total cost of ownership. Transit agencies are looking for ROI, both in terms of environment and dollars. And without managed intelligent charging, efficiency and savings are largely lost. And that's because it's just way too dynamic. There's too many variables affecting all of this. Terrain, temperature, idling, driver behavior, route deviations. This makes the deployment of a dedicated charge and energy management system fundamental to a successful electromobility campaign. And I'm going to wrap it up there. Hand the mic back over to you, Grace.
Thanks very much, Will. Really detailed presentation. We'll get into a couple of Q&As after the last presentation. So thanks, Will. Over to you, Alexandra from Hitachi Energy. Last presentation. Here we go.
Yeah. Okay. Thank you very much, Grace, and good morning, everyone. A special thanks, of course, to the entire QTRIC team for giving us the opportunity to sponsor this session and be part of this great discussion. So I think my slides have moved. Just give me a second. Go back. You guys got a sneak peek. Okay, good. So a little bit about myself. I'm Alexandre Lalonde. I've been working in the EV space, especially in the medium duty and heavy duty charging infrastructure since 2017. I now head the business development activities for the charging solutions that Hitachi Energy offers for the North American market. So before diving into the innovative solutions that Hitachi offers in this segment, so I'll just start by introducing you to the Hitachi Group. Okay, great. So Hitachi's mission statement is to solve the society's biggest and most challenging problems with creative and innovative solutions. Some of you may already know Hitachi from our construction machinery business, our trains, or perhaps our TVs. So we're very much present in all countries around the world in both OT and IT sectors. And as you can see from this slide, we are firmly dedicated to innovation with and even with the recent acquisition of Global Logic, who provides digital product engineering services and complements our extensive software capabilities that Hitachi Vantara already had. It is fair to say that Hitachi is really growing into a main player in the IT world as well. Now, Hitachi Energy, a few words about Hitachi Energy. Hitachi Energy was created from the acquisition of the power grids business of ABB, which was actually officialized in 2020. So some of you, especially the QTRIC team that we spoke with last night, were kind of puzzled, that with the name changes of big organizations like this. We went from ABB to ABB Power Grids and Hitachi ABB Power Grids, and now it's official, it's done. It's Hitachi Energy. So we're an established leader in the industrial and power utility markets, providing leading edge technologies and services around the world. And we've been taking part of the transportation electrification for a very long time, developing solutions for the railway markets. However, as of 2013, we really took an active part in the transit bus electrification with the development and the deployment and demonstration of our flash charging technology, which was at that time charging BRT buses in Geneva up to 600 kilowatt per 15 seconds, so both en route and at the depot. Now, just a quick glimpse at our sustainability goals. Hitachi Energy has set very bold targets in line with the very important challenge that climate change poses to us. So effectively, we're targeting reaching carbon neutrality in our operations globally by 2030, which is a very bold move. And back in January, we already announced that we reached 100% renewable electricity at one of our largest production facility in Ludvika, Sweden. So just showing the commitment. And not only do we work extremely hard to reduce our carbon footprint, but we're also looking after the complete spectrum of global challenges to further improve our impact as a corporate citizen of the world. Now, let's look at the innovative solution that Hitachi brings to the table in terms of the charging infrastructure for transit fleets. So our team at Hitachi has really looked at the upcoming full-scale, the necessary full-scale electrification of transit systems, and essentially found that the currently available technologies relying on distributed individual, cabinet technology was not addressing most of the critical challenges in electrifying a transit fleet. So we kind of went back to the drawing board, starting from a blank sheet to design a system that would be robust, more efficient, modular, and truly scalable for full-scale fleet. And this is how we came up with our centralized rectification charging technology, and really it is game-changing. So here's some key differentiators of our approach. First, instead of converting AC to DC, AC to DC power, and each and every, what we like to call refrigerator-style cabinets, we do it in bulk with a rectifier transformer lineup that comes from the railway industry, and that we specifically picked for its track records, its robustness. So then what we do is that we feed this DC power, this bulk DC power, through a common DC bus to a series of DC-DC converters that now become essentially the chargers. Which are then connected to remote charging interfaces. So that's kind of in a nutshell the architecture of the system. And so the charging interface can have the smallest footprint, because we never have, we don't have space generally speaking in the depot, but especially around the vehicles. So naturally, these interfaces can be either a CCS cable, the pantograph, that's no problem. So an important advantage of this very condensed architecture is that it allows us to support input voltages at both low voltage and medium voltage levels. Very important when you reach very high power. And also the DC bus effectively replaces that typical, low voltage distribution spaghetti that you have around the depot to feed all of these distributed boxes. So I'll try to go quicker. I'm getting some time checks here. So as you can see from the slide, this is with this architecture, we can achieve substantial space and cabling savings. At the same time as we reduce substantially, at the same time, we also reduce substantially the system complexity and number of components. So one cabinet, as you see here, can hold up to 100 kilowatt DC modules, which are rack in, rack out for ease of service. Now, let me just see. All right, good. So I'll just skip a couple of slides. Okay, I'll keep it to the very minimal so we can go to the Q&As very quickly. So we use the same architecture, and components in two different delivery models. Our classic delivery model is essentially taking our technology components, sizing them up to meet the operational requirement, installing them either in existing buildings or delivering them in tailor-made prefabricated buildings. So that's what you see on the left side. On the right, in the classic model, we can deliver individual lineups or systems rated up to 3 megawatts. for one system, and then we can duplicate these systems. On the right side of the screen, you have what we call our integrated models, which are using the same technology, but coming in predefined, pre-configured, and plug-and-play systems. So very quickly, all right, I'll just wrap up with this this final slide, and then we want to get to Q&A very quick. So I just wanted to touch on the digital integration of these charging systems. So the overall digital ecosystem is an essential component of a successful full-scale deployment. I think you've seen it from a couple of presenters today. And so Hitachi is offering really a full suite of modular solution, ranging from the remote monitoring, the control of charging infrastructure, the smart charging modules, and really to ensure control over the cost of operations. But also we offer very important and exhaustive service and predictive maintenance for both the vehicles and chargers to further optimize the operation. So in conscious of time, I'll stop here. I'll be glad to connect with anyone who'd be interested to pursuing this conversation or learn more. So thank you very much, and over to you, Grace.
Thanks so much, Alexandra. I appreciate you trying to get through your presentation as quickly as possible. We do have lots of questions coming in, so we'll bring everybody back. I'll just set the scene a little bit after all of your presentations, really to, why are we here? Milford had mentioned that transportation is 40% worth of Canada's GHG emissions. It's a substantial amount. So moving forward, we've got the mandates in place. We've got the 5,000 zero emission bus mandate. We've got the $2.75 billion federal zero emission transit fund. That is all in place now. So with that, the demand, is going to increase, and maybe it already has. And I know a little bit because we have our Canadian ZEB database at CUTRIC. We're tracking everything that's going on and helping those transit agencies. But I wanted to ask, what does the market really look like today, and what demand are you seeing from this charging solutions perspective? So Paul, maybe I'll turn it over to you first.
Yeah, sure. So it's fairly early days unless you're a fairly large metropolitan area like, TransLink and TTC, and of course, City Edmonton went first. Unless you're a large property like that, if we take the presentations that we've seen, an excellent job by everybody, it's all very relevant. The bunch of us would have a heck of a beer conversation, I'm sure. But the reality is the industry in Canada particularly is not there. If you go to Europe, they're quite a bit ahead of us. There are products that do a lot of this, a lot of transit agencies deployed, but I think it's right around the corner. And that's because you now have even mid-sized properties putting their hand up going, I've got 120 buses. I know I can't do this on a magnet board. So how's this going to work? And they're going to need every one of us here in this session.
Yeah, 100% agree. And moving into this, I know like at CUTRIC here, we're big on interoperability with our battery electric bus trial that went out the door with York Region, Brampton and TransLink. All of those buses and chargers were interoperable. Will, you touched on it slightly in your presentation, and the fact that you have that interoperable kind of outlook on life in it. So does Init have an integration capability with operational systems by providers other than Init? You're on mute.
Thank you. Yes is the short answer.
Appreciate that. Milford, do you want to chime in here? What are your thoughts on interoperability? I know that you're thinking more so of a holistic approach. It was really interesting to hear that in your presentation.
Well, that's really, to me, the secret is we've got to integrate lots of different things to make these work, and being able to integrate transportation into the living environment. We started developing these sustainable communities, and we realized, what? The grid here in Ontario is pretty clean. So the actual carbon footprint of a building is not as significant as in other parts. But we got this transportation. People got to get in and out of the community. So we really need to address transportation. And that's kind of how our journey got to this, and why we feel it's so important to look at a holistic kind of a view of things.
I really appreciate that. And I loved your opening remarks. I love innovation. I mean, I think everybody at this conference can agree with you, Milfred, there. We are all in the same boat, and it's great to see your passion across this
But
panel.
it not only is innovation in technology, we have to take that to innovation in business, innovation in finance, and we're not there on all the way through the chain. The technology is way ahead on innovation, is my opinion.
I love it. Yeah. Challenges all the way through. I think a great version or a great example to look at the financing aspect is the CIB and their support through the financing mechanism with their $1.5 billion. So, we're getting there, but yeah, you're right. There's so many challenges that this industry really just needs to overcome. Tanya, going over to you now, really interesting to see the progress you're making with Durham Region Transit. Take us through a little bit about eCamion's growth. I know you've had, a huge growth over the past couple of years, especially since being created 8 years ago. But, are there any timelines you can provide us for Durham Region Transit pilot? Can you give us some insight there?
Yeah, absolutely. So, you're right. We've been on a heck of a growth journey. And when I think about it, the last 4 years have really, I think, been pivotal in that there's so many use cases for this technology, and really learning on a use case by use case basis has informed us and helped us make the value proposition more wholesome. You can hypothesize these things, but then you get out into the field and you actually, start learning in real time, and it's no longer virtual, and you've got to adjust. I think that for us, the big key is, what we had the opportunity to develop the inverted pantograph thanks to the support of QTRIC. And actually, Paul and I go back to the case in Edmonton through the ERA as well. And so it's this fabulous support and funding, along with the willingness of partners to step up and create a space for us to plug in. Durham is actually, we're really proud because they're local, they're willing, and it's actually on that pilot is really underpinned by the development that has been supported by QTRIC and by ERA. So we're happy to get that traction in real time, and we look forward to sharing those insights. I think the one thing that you talked about in terms of standards and interoperability, there still has to be far more sharing going on than there presently is. So while the standards are out there and they're dictating at the high level, the granular level of how that actually works out, given specific technologies and pilots, that's still not readily shared. I'm looking forward to QTRIC eventually finding a solution for that level of sharing.
Yes, it's such a good point. And this is, all we want at QTRIC. We have been fighting for our ACES Big Data Trust, which is really that national trust across the country, bringing in everything, because without data sharing, you're on your own, right? And we all know that collaboration, especially in this industry, is absolutely key to success and to making things just, quite frankly, more efficient. So a great point, Tanya. Really great words there from you. I know we are running out of time. Alexandra, I want to pass a question over to you. What to you has been the biggest surprise in this industry? What has really changed things for you, and what's surprising about everything that's going on with all of these great innovators here today?
The speed. I think the speed is really what keeps surprising most of us, I think, every day. Because I think Milfred mentioned that the finance, the operations, all the innovation and these other aspects are not keeping up with the technology. But I would say even to first.
Oh no, have we lost Alexandra? Oh no. Oh right. I think we got his comment. Speed is really the key to this. Paul, do you want to jump in quickly?
Yeah, no, just in terms of innovation, totally agree with Alexandra in terms of speed. And in fact, I'd like to put it the other way around and say it's not moving fast enough. The timeline to take advantage of things like ZETF and other funding, it means that people have got to be right on it and go. And and if you don't have applications in for planning, or if you're past the planning and for capital, you need to get on it. If you need help, there's all of us on these conferences that are presenting. Give me a call. Give any of these folks a call. We can help you. Let's get going now, because to meet 2030 targets, not going to happen the way that things are going, despite the pace of the technology, which I agree with.
Yeah. Sorry about that. I was cut off right when I was talking.
Just into the meat of it.
That was just I guess that you got the gist of it, and I think we need to as an industry, step down, double down on efforts to make it even faster. But really, what in terms of the surprise, what surprised me is the level of involvement and commitment that came from governments that really stepped up, and provided that gap, helped to cover that gap of financial help to expedite, that much required transition.
100%. It's been a long journey to get there. We've known for years that federal governments just really need to support us. Provincial governments, municipal governments, they're all here. They're all coming to the table. We have climate action strategies now. So I think we're in a really good place. With that, I know we're running out of time. So what I want to do is a rapid fire. If you could give maximum 10 words of recommendations to the folks on the line today, what would that be? So Milfred, I'll pass it over to you first. And you're on mute.
Hire psychologists and human behaviorists, because we need to change the status quo. The technology is here.
Amazing. It's so true. I love it, Milfred. Tanya?
Be open to different ways of funding, engaging, collaborating. The better we are at working together, the faster we're going to get there.
Great words, Tanya. Will?
Yeah, I would start by saying hire consultants like Paul and think past the pilot stage.
Yeah, absolutely.
Amazing. Yes, that's something at Qtrick we're always saying. Why do a pilot when you really want to get this technology on the roads? And this technology is here to stay. We're not going back to diesel. We're only moving forward. So think smart, be smart. I don't want to take any words out of your mouths. Paul, over to you.
Yeah, real quick. I couldn't agree more on the pilot comment. There's no need to pilot. Just move forward and get started right now. Give people a call. There's people that know how to navigate the system. Let's get projects stood up. We got OEM implementers like Will and his company. We've got product OEMs like Alexandra. We've got eCamion. We've got all these high technologies. They're available. Just let's get projects started. Let's go.
I love it. If you were on the Root I panel or the Zeb Consulting launch panel yesterday, Ralph Nielsen from TransLink, the first recommendation he had to transit agencies on the line, just get started. So we're all in the same boat here. Alexandra, final words, over to you.
Yeah, I mean, I'm going to echo a lot of my colleagues' comments here. It's no matter where you are in your electrification journey. Some of them, there's smaller agencies, as Paul was saying, we don't necessarily have all the funding from great big agencies. So no matter where you are in your journey, think of your full electrification plan, not just today, not just getting it done for this 1 or 3, 2, 3, 5, 10 buses. Think of what it will look like and prepare for that today. That's going to give you the right learnings.
Appreciate your insights. So everybody, thank you so much. Panelists, you've been brilliant today. Incredible presentations. This panel will be available for in demand starting next week. So for those of you who want to revisit the insightful presentations, you know where to go. Thanks again. Thanks to our audience for joining us. We have more panels and more keynotes to come today, a networking session at 3:15 Eastern time. So stay tuned. Join us in the next session. It's beginning at 11:15 Eastern.